As you might expect from our introductory video on NumPy, each ND array has its own data type. We'll quickly look how to set and inspect that type. Moreover, we'll look at a wide range of ND array operations. So, by the end of this video, you should be able to examine and set the data type of an ND array. You should be able to use common ND array functions. As we showed you previously, data types matter. If you try to assign an element in an integer array to a floating point value, you'll get an error. Let's start by just doing some basics with these. We'll start by creating an array and giving it two integers. The type of the array is unsurprisingly going to be an integer. Similarly, if we give it floats, we're going to get back a float array. We can also explicitly say the type we want by creating the array. Here, we're saying that we want the type to be integer. Where this gets useful is when you want to force a different type than the input. Here I'm providing two floats to the constructor, but I'm telling it to make the type integer. NumPy will do this. It just forces the floats to drop their decimal, effectively doing the floor function. Similarly, we could force ints to be floats. This is less problematic because we're not losing any information. The reason you might want to do this is if you presently have integer data, but expect for the values to change to be floats in the future. You don't want Python to pick int data types here, only to run into problems later. Just keep in mind that data types matter for ND arrays. Next, let's look at some of the common operations on ND arrays. Most of the arithmetic operations you might expect are here. Let's start by creating a couple of arrays. Notice that the first is integer and the second is floating point. For most of our arithmetic operations, the results will be upcast to floating point to avoid losing precision. Also notice that these arrays have the same dimensions. For many of these operations to work, there needs to be an aligning of dimensions. In this case, the dimensions are the same, so we'll be fine. But later we'll see that there is some flexibility about this constraint when we learn about broadcasting. So let's get started by adding. We can do this either by using the plus sign or using the np function add. They'll both produce the same result, and the plus sign is better for code readability. With add, this does exactly what you'd expect. Element 00 of x is added to 00 of y to produce the new 00 value, and so forth. As I mentioned, the results here are floats to avoid losing precision. We can also subtract arrays, multiply arrays, divide arrays. We could perform square root on all the elements of an array. And we could also do e to the x for all the elements using the exponent function. Next, we'll look at some other common functions in NumPy, including those for basic statistics, sorting, and set operations.